All right, hello, you guys. So I just recorded what I thought was like 15, 20 minutes of stuff, and it wasn't recording. So I'm going to start again. Here's our agenda for today. So I want to make sure that y'all are aware of kind of the goal for this short video. Let me first say that I am not going to fit an hour and a half like what we typically would in a class period. We're not going to do like a warm up. We're not going to do a closing. We're not going to do an activity or like a worksheet or anything like that. So I'm going to kind of like boil down the material to what I think is the most important. I'm going to do a short little mini lesson, and then you're going to practice a few. We have basically learned everything for our unit exam, but obviously we can't do a unit exam, a traditional unit exam anyway, and we also need to review. So what I'm going to do today is review half angles, and then tomorrow we're going to put together double and half angles, and then we'll kind of work backwards and kind of put everything together. So over this week, I'm not really teaching you anything new, which is kind of nice, but I am teaching you or reminding you of some of the old stuff. So the first thing is you need to have 18 flashcards made. If you have not already done them, you need to do so now. Okay, well, not like immediately now, but over the next couple of days. When the sub was there last week, you should have made 15. I think honestly, if I'm thinking back to it, I think I might have forgotten the Pythagorean identities when I asked you guys to make your flashcards. So if you didn't do these three right here, make sure that you got those in there. Okay, so if you want to like pause the video, you certainly can. To make sure you get all 18 of these, but I tried to be really clear about what should be on the front and what should be on the back. Remember, these formulas right here are not necessary. You can totally pick just one of them. I told you those two would be a point extra credit each if you remember those. Same thing down here. If you don't want to memorize both of them, if your brain is like, I can only handle one, just memorize the first one and then don't worry about the second one. Okay, so flashcards should be good. And here are the formulas. I think everybody except for one or two people were here on Wednesday, the last day before our break. And so everybody should have these half angle identities, but if you weren't here, make sure you're getting these down. They're also on the flashcard page, but this is, you can tell they're half angles because, it's taking x, some angle, and dividing it by 2. Okay? When it's sine, the sign is opposite. I say opposite. What I mean by that is it's going to be negative. The word is sine and the word in here is cosine. So to me, they're opposite words. They're not the same word. So the sign is going to be different. Here, when it's cosine, they're the same word. And so it's going to be the positive sign. Okay? All right. So I went ahead and worked this a moment ago when I thought it was recording me, but it didn't. So I'm just going to pull this up and see if it makes sense to you, okay? The first thing I want to note is I want to make sure everybody is clear that this means quadrant 4, because 270 degrees to 360 degrees, okay? Also, with this being a negative here, that means either the 4 or the 3 is going to be negative, and honestly, you don't really know until you draw the picture. So make sure you draw the picture appropriately, and then because of SOHCAHTOA, 3 is going to be the O and 4 is going to be the A. And so then I did the Pythagorean theorem here, but I hope most of us are recognizing the Pythagorean triple 3, 4, 5, as long as our legs are 3 and 4 and the hypotenuse is 5. So I came down here. This is probably the most important thing. On Wednesday, Demerica helped me remember that I forgot my negative. Or no, I remembered it, but then I lost it along the way, which is a very common mistake. So I hope that it's a lesson to learn that if the teacher that's used to doing it forever messed it up, it's very easy for students to mess it up as well. So we use the negative when our theta or our angle is in quadrant 3 or 4, and so because this problem is in quadrant 4, we definitely need to put the negative out front. All right, so I'm just literally plugging and chugging the formula. So I find the cosine value, which is a over h, my 4 and my 5, and I plug it in here. And then I get the common denominator, so 5 over 5 plus 4/5, so that gives me 9/5. And I made this fraction. You do not have to put the 1 on the denominator, but I did, so it'll help me remember to do keep, change, flip. And so now that's what I did over here. 9/5 times 1/2, because I changed the division of 2 to multiplication of 1/2. And so then I multiply straight across, if you remember. So 9 times 1, 5 times 2. And then when I take the square root of a fraction, I am going to square root both of the numbers. So the square root of 9 and then the square root of 10. Now, this is where the note-taking thing got very difficult for me, and it was kind of messing up a lot. But I hope everybody is clear. Here is not your final answer. You have to rationalize the denominator. So we would go -3 root 10 over 10 because of this rule, rationalizing the denominator, if I can get this to work. Okay, and so once I can get this to work, just to remind you guys, that's how I'm getting this final answer right here of -3 root 10 over 10. Okay, so let's go to another one. Let me erase this so y'all can kind of make sure you understand before I just say here's what the answer is. Okay, so I should have that this is in quadrant 3. Okay, sorry, that's pretty Miss Thomas fashion, not very neat, but that's okay. So we have our opposite and our hypotenuse, and I did Pythagorean theorem and got a nice perfect square. The one big thing I need to make sure you remember is this negative is not going to be clear from the Pythagorean theorem. You have to remember that from the picture, that because it's in quadrant 3, the x and the y should both be negative. Okay? And then I'm just going into the formula again. So I'm going to do 1 minus cosine. This time it's, as opposed to the previous problem, it's going to be 1 minus instead of 1 plus. Notice here, it's going to be a double negative. Okay? Because we have 1 minus and then a -8 over 17. You can see in this next step here, my computer was my iPad was messing up. Let's see if it'll do it this time. Nope, same thing. So that was happening earlier. So that should be plus. It looked like I was making a times sign. Okay. Sorry for the technical difficulty. Okay, so then I'm adding the numerators, keeping the denominator. That's how I get 25 over 17 here. And then I'm going to do keep, change, flip again. So times by 1/2 and get 25 over 34. And then again, the 25 is a perfect square, so it becomes a 5. This won't happen every single time. It does happen a good bit, but it's not always. And then 34 on the denominator. Root 34 is not a perfect square, so we have to rationalize the denominator. And so, I don't know. Okay. And so our final answer, now I can put it back up, should be 5. Ooh, that's a pretty color. Root 34 over 34. Okay, that should be your final answer. So take a minute to pause if you need to do this yourself or work through it. You certainly can. Okay, now I'm actually going to see if I can work through this last one and not mess it up too badly, but we shall see. Okay, that purple was nice. Let's do it again. So cosine is adjacent over hypotenuse. And we're in quadrant 1 because of this statement right here, 0 to 90. So adjacent's going to go here, hypotenuse is going to go here. We're going to do Pythagorean theorem. 1 squared plus b squared equals 4 squared. Okay, so I'm going to do 1 plus b squared equals 16. And so then b squared is going to equal 15. And b is going to equal root 15. All right, because we're in, oh my goodness, it's like the margins, it doesn't like the margins or something. This will be root 15. And the reason it's root 15, or positive, is because we're in quadrant 1. All right, so now we're going to do the formula. This is probably one of the few cases, I think I said this on Wednesday, that tangent is probably the easier of the two, honestly, for once. Okay, so our formula goes 1 minus cosine over sine. So this one does not have a 2 in it, like the other ones do, the sine and cosine formulas. All right, I'm going to have to work around this program a little bit more because it might also be my stylus, but I apologize. Okay, so we're going to do 1 minus, our cosine is our adjacent, oh, we already had that in the problem, so 1/4. And then our sine is now the root 15 over the hypotenuse. Oh my word. Okay. So we're going to get our common denominator like we've kind of been doing all along. So this is going to be 4 over 4 minus 1 over 4. And I'm just leaving the denominator for now. And so now I will have 3/4. And I think y'all can handle this. I'm going to do keep, change, flip at the same time. So I'm going to end up with this when I do keep, change, flip to multiply. Oh my word, sorry. Okay, so do y'all see here on the diagonal we have a 4 and a 4. So remember how we did cross reducing. So those can go away. So our not final answer, but almost there, is 3 root 15. 3 over, root 15. Oh. And then, as we know, we can't leave it like that. So we're going to rationalize the denominator. So we're going to times both the numerator and the denominator by 15. Something like that. And so then we should have 3 root 15 over 15. And then that's actually not our final answer because of this fraction right here. 3 over 15. And so 3 can go into both of those. So our final answer is root 15. Oh my word. Root 15 over 5. Oh, saving note. Right on time. So let's see if I can get it to circle this as our final answer. Okay. All right. So I apologize and I'm appreciative of you bearing with me. I hope you're still with me. Anyway. Okay. So I have 3 problems I'm going to pull up. You can pause the video now. I want you to do it on your own paper. Numbers 4, 5, and 6. It is one of each. Sorry for the handwriting, but I think y'all can read it enough. Make sure you sketch. Remember the thing that is, I would say, the biggest common misconception or mistake that students make is the negative. So once you draw your picture, make sure what's negative is supposed to be negative, even when you do Pythagorean theorem. All right, good luck. Please submit these to me through Remind or my email. I don't care. Either one is totally fine by me, whatever you feel comfortable with. Should I put that up just to make sure you know what my email is? I think we know, but it's Thomas D. at, you know the thing, McDuffie. But so you can do that, or you can just send me through Remind. That's fine as well. I miss you guys a lot, and I hope y'all are doing okay. And please let me know if you need anything. If you have any specific feedback questions, you could even like make a video and send it to me through Remind as well. All right. So good luck, and we'll chat later. Bye bye.